You ever get that feeling when you click on a microscope that looks like a piece of lab equipment from a sci-fi movie, only to discover it's more of a decorative paperweight once it sits on your desk? I've seen a lot of people waste weeks and a few $100s chasing that promise of professional-grade performance, only to end up struggling with dim images, shaky focus, or a setup that takes an afternoon just to get the camera mounted. That hesitation is real, especially if you're trying to decide whether to invest in a high magnification system for a college biology class, a home hobby lab, or a small research project. Link is in the description if you want to check the product details on Amazon. In this review, I'm going to walk through exactly what you'll experience with the AmScope T690C PCT200INF, point out the hidden trade-offs that aren't obvious from the product photos, and help you decide if it's worth the price tag for your specific needs. First off, the category we're dealing with here is a trinocular compound microscope that claims both Brightfield and phase contrast capabilities, plus a built-in camera mount. That combination is usually targeted at users who need to capture stills or video of live specimens. Think students documenting cell division, hobbyists filming pond water, or small labs that need to share images with a colleague. The real test, however, is how the microscope behaves when you actually try to use those features in a day-to-day workflow. When you unpack the T690C, the first thing you notice is the fairly large optical tube and the 3 eyepieces on the trinocular head. The extra third port is where the camera would sit, and AmScope provides a vertical mount that slides up and down. In practice, that means you can keep your eyes on the specimen while the camera records, but you have to be mindful of the balance. If you attach a heavier camera, the whole head can tilt forward, which forces you to readjust the focus knobs constantly. For most users who are happy with a lightweight USB microscope camera, the balance issue is manageable, but it does add a small learning curve that you won't see in a simple monocular unit. The illumination system is a halogen lamp with a rheostat. Halogen is great for getting a warm, even light, and the dimmer lets you dial down the intensity for delicate live cells. The downside is heat. After about 10 minutes of continuous use, the lamp gets noticeably warm, and on a cramped lab bench, that extra heat can affect temperature-sensitive samples. If you plan to run long time-lapse recordings, you might need to give the lamp periodic breaks or consider an external LED source that you can clip onto the microscope, something the T690C doesn't provide out of the box. Now let's talk about the optics. The nosepiece is reverse-mounted, which is a bit different from the standard forward-facing design you see on most educational microscopes. It holds 4 objective lenses, 4, 10, 40, spring-loaded, and 100 oil immersion, also spring-loaded. The spring-loaded lenses click into place with a satisfying thunk, and that makes swapping between low and high magnification fairly quick. In real use, the 40 and 100 lenses give you the detail you'd expect for cellular work, but the quality of the glass isn't on par with high-end research microscopes. You'll notice a slight loss of contrast when you push the 100 oil lens to its limits, especially if the slide isn't perfectly clean or if the oil isn't applied evenly. For a student lab that's looking at onion skin cells or a hobbyist examining diatom frustules, the images are still clear enough to make out structures, but you won't get the razor-sharp resolution that a dedicated research-grade system would deliver. Phase contrast is a headline feature that can be a game-changer for watching live microorganisms without staining. The T690C includes a phase contrast condenser and a set of phase rings that line up with the 40 and 100 objectives. Setting it up the first time can be a bit fiddly. You have to rotate the condenser to the correct position, then align the phase ring with the objective's ring. Once you get it right, you'll see transparent organisms like paramecia swimming with a halo that makes them pop against the background. In practice, though, the alignment is sensitive. A slight nudge to the stage can throw the whole phase contrast effect out of sync, forcing you to readjust. If you only need phase contrast occasionally, that extra step isn't a big deal, but if you're planning to run a series of live cell experiments, you'll end up spending a good chunk of time tweaking the setup. The mechanical stage is double-layered with 1mm divisions and a stage stop. That gives you a decent amount of control when moving a slide incrementally, which is useful for stitching together larger fields of view. The stage stop is a nice safety feature that prevents the slide from sliding off the edge when you're adjusting focus at high magnification. However, the stage feels a bit loose compared to more expensive models. The knobs have a little play, and when you're using the oil immersion lens, that wobble.